we've got, one of the questions on the assignment is this, you've got to differentiate it and then double differentiate it again, so double differentiation. Sorry?
Is that a G code?
That is G for gain. So what it's saying is the gain of an amplifier is found from this expression 20 times log 10V, V's for volts. So the gain of that amplifier is linked to this formula. And this is what we actually do use for gain of amplifiers, very similar formula. When you've got log like this without anything written at the bottom as a base, it usually means it's base 10. So on your calculator you've got two log buttons. One's base 10, so you say LOG, and the other one is this one, LN, which is natural logs, which means basically log to the base of E, Euler's number, the exponential of X. If you remember, I told you that you can't use any other logs when you're doing calculus, whether it be differentiation or integration, you can't use any other logs other than natural logs. So if we get landed with this, we can't differentiate it as it comes. So what we've got to do is we've got to convert it into natural logs. And this is the formula to convert it. This 3 lines means it's identical, an identical result.
Oh, there's 3 lines there.
Yeah, instead of 2, it's like equals, but it just means identical to. It's an identity. It's not important, just put 2 lines if you want. So what it's saying is, if I've got some base to the x, I can convert it to another base, a new one by going to the new one and dividing it by the new log, but with the old base inside the brackets. You okay with that?
Yeah.
So it's quite straightforward actually. This might look tricky at first, but it's actually quite straightforward. So what I've got, if I take this, I can rewrite it with my new base of this. So the 20 goes outside. Yeah. That's not relevant to it. That's just a multiplier, a constant, a coefficient. And then I've got my natural log of 10V divided by natural log of my base, which is 10. Yeah. You okay with that?
Yes.
Straightforward. So that is identical to that, in other words. So all I've got to do, I've got to do a bit of adjustments and then I can differentiate it. So we're going to differentiate, we can only differentiate this bit. This is, remember what I said, when a number's not got a variable in, it's not got V in it, you can't differentiate it. So all it is actually is just some number multiplier that's out front. So all I can do is just bring it outside like this. So I can bring that outside because it's just a number. That's all it is. Log 10 is a number, whatever it is.
Is that LN next?
Yeah, for natural logs. LN for natural logs. And then this is the bit that I can differentiate. I don't know why I've got such a big bracket. Okay? Log of 10V. In fact, I don't even need so many brackets. So that multiplies that when I've differentiated it. It's just like the coefficient out front. So I'm ready to differentiate, simple as that. So what is... Sorry?
Whatever's in the bracket stays in the brackets, isn't it?
Right, this is slightly different in this actual one example, despite everything I've just told you before. What's the derivative of log? Well, what's the derivative of log V?
Log N.
Right, when you do a natural log of V, this one, right, just think of it being an X, for example. What is the differentiation of log V, of the differentiation of log X?
1 over log 1.
Yeah, 1 over X. So this is going to be 1 over V. You remember I told you this, and we saw this when we did the chain rule. What is it when it's got a number in front? So in other words,
1 over.
No, it goes in front.
In our case, 10V. What's the answer to that one when we differentiate that?
1 over 10V. Was it ln 1 over 10 V?
Right, it ends up being the same. The actual literal answer is this, which is the same as 10 over 10 cancels down to 1. So you just end up with the same answer. So in other words, the number in front of the V disappears. So all that I told you about what's inside the bracket stays the same, and it doesn't in this one case. There's always got to be a contradiction, just to confuse everybody. So the differentiation of this is going to be the differentiation of that. Let's put this outside.
So the 10 comes out.
It's basically going to be this. So times the differentiation of this. So I'm going to get 20 log of 10 times the derivative of this. So the log is just 1 over v. Yeah, like that. Simple as that. And if I put that numbers into that, I've got oh, that was my example. Somebody want to do this for me? 20 divided by log 10. You can't both be right.
What is it? What the?
20 divided by log 10. Which log have we used? That's the question. That's the right method. 8.6. 8.6. 6, what's the numbers?
8.5.
8. 685. Like that.
How does that work out?
Okay?
I got 28.6135 Q1.
Probably using the wrong logs. Should be natural logs. LN.
Oh, LN. Oh, right.
Yeah. So, and it's all over V, is it not? So that's it differentiated
I
once.
got 12.42.
So yeah, I got 8.685.
That's the right answer, I remember it actually. I've got the answer somewhere.
20 over LN. 5 in it or 10 did you
So
say?
do you log or learn? Which one?
It's natural logs, LN. The second,
It's the learn.
not the LOG, the one that's on the right of it.
Or the learn.
The LN. Well, just think of natural logs, LN, natural logs. It doesn't come from that probably, it probably comes from the guy who did a lot of work on the guy called Napier. Okay, actually. But never mind, it's fair enough. it's fair
Zen
enough.
likes to work on the LN.
Yeah, we won't go there. Okay, so I need to differentiate it again. Let's lose this. I need to do a double differentiation. What have I got? G. So I need to differentiate this
Wouldn't
again.
5b6 to round it up? 8.6.
It might be. I don't think that's important at this
Okay.
stage. But I need to differentiate this again. What do I need to do so I can differentiate it?
U and V.
I think you're on the right lines, yeah. I can't differentiate as it is, I need to bring V to the top.
Yeah.
So basically I'm going to be going like this, 8.685 I'll leave it as, and it's V minus 1. So that's going to give me, what's that going to give me when I differentiate it here?
Minus,
No.
I think you're there, yeah. Minus
minus that number.
8685
V minus 2.
V minus 2, very good.
Minus 2.
Which I can write like this, can't I? 8, 6. Why have I taken to forgetting my decimal place? 8, 6, 8, 5 B squared. Same thing, yeah?